7 Quality Contributors, Part 1. Quality Management. Quality management has taken an evolutionary path, and in its existence, a lot of people have contributed to the field in terms of disciplined thoughts and systematic actions. Throughout its evolution as a supporting field to the main branches of engineering management, quality management has brought in spectacular ideology to product differentiation, cost leadership, and continuous improvements. In management practice, quality management and control has a vital part to play in making sure products and services produced by the industrial management segment caters to standard outputs in controlled environments. So in this lecture, what we do is we are going to go across some of the eminent personalities who have shaped the quality landscape with their unique contributions in terms of their introduction of quality metrics, frameworks, methodologies in the engineering management landscape. 7 quality contributors. So we will see who these people are. Jenichi Taguchi, Joseph Juran, Kaoru Ishikawa, Noriaki Kano, Phil Crosby, Shingo, and Deming. So these people, we will take a look at their contributions and what they have done in the field of quality management and quality control. Taguchi. Taguchi was a Japanese engineer and statistician whose principal contributions included making sense of what product specifications meant for quality and in getting a disciplined way of obtaining or translating product specifications into cost-effective production. Taguchi explained what is called a loss function, which is a continuous decline in utility when one moves far away from a target specification. For instance, let us take the food which is cooked. It may be acceptable at a particular temperature. However, may remain unacceptable, may be too burned or may be undercooked at a further increased temperature or very decreased temperature, since it may get overcooked or burned or might be undercooked. He advocated quality through a design summary. According to him, a product remained acceptable within a particular set of product specification beyond which a product was not acceptable as per the quality guidelines. His definition of loss function involved deviation of the product performance on quality service content to the extent a deviation is termed as a loss to the product's performance and in turn to the consumer of the product over the lifetime of a product. Also, he thought that double the deviation felt in terms of loss function of a product, quadruple is the actual loss felt by the consumers of the same product or service. Also, he wanted the loss function to continue in such a manner that continuous improvements to the product reduce deviation, loss, as well as streamline the product's specifications. Taguchi's ideas on parametric design and control of experiments have a lot to do in manufacturing, where he believed the product should not be fine-tuned to minimize worker efforts, temperature and pressure of the working environment. Instead, the quality management should work on minimizing its effect on the final product or service. Next are his views on experimental design. Experimental design, though invented by Taguchi, was a well-established body of knowledge in the field of statistics. In statistical analysis, a lot of experiments need to be carried out to find out about sensitivity parameters. But using Taguchi's method, the amount of work gets drastically reduced. The objective in Taguchi's method recalculates methods to reduce noise in the system by systematically changing the design parameters by observing the output or the outcome of experiments. For Taguchi, it's a product design that makes the difference, and he draws attention to differentiating between online QC, online quality control, which is QC during manufacture or in prior steps design, and offline quality control, which is QC, concerning sensitivity tests and reliability tests. Hence, product design and product development take center stage in Taguchi's method of quality management and quality control, where he splits product development into system design, boundary design involving parameters, and tolerance design. So we'll see what each of them means. In system design, marketing and customer knowledge is taken alongside engineering for prototyping. In boundary parameter design, product performance is earmarked or analyzed based on changing boundary parameters. So whenever there is change in parameters, boundary parameters, we have this boundary parameter design. In tolerance design, targets are assigned tolerance levels, not based on an engineering perspective, but on a trade-off between society loss, that is loss function, and production or manufacturing costs. So this sums up the part 1 of quality contributors. We'll be discussing about the contributors who are remaining in the subsequent sections. Thank you.